But this is where we one of the few, well, one of the second to last slides from last week. So let's just review it quickly while we wait on everyone.
The spirit tells Pelagio that the Duins will only set the soul of her son free if a human gives them half the gold within the caves. The Lajables makes Pelagio promise to give up half.
I promise, now tell me where this vault is.
Be warned, mortal, I am not to be deceived.
All right. And we all have our doubts about Pelagio, right? Remember last week I asked you all, do you think Pelagio is going to keep up his end of the deal when he finds that gold in the cave? Will he really give the Dwens half? Right?
As Pelagio journeyed through the forest, he could swear he heard the animals and trees whispering to him. He could hear voices, but could not make sense of it. He ignored it and concentrated on the gold.
Right? And those are the animals and the leaves of the forest trying to tell Pelagio to keep his end of the promise. Right. So last week we were on something called isomers, right? So last week you were able to take down this note about isomers, but I really did not get a chance to show you exactly what an isomer is, right? On the screen here, right, to the left-hand side of the screen, I would like you all to name this alkene. And we know it's an alkene because there are only single bonds. And I mentioned that over and over. Could you name that alkene for me and send it on the chat? And let's see how much you guys remember from last week. Go back in the notes. Last week, when we were naming alkenes, we first had to count how much carbons it had. So let's count it up. I think some people counted wrong. 1, 2, 3, 4, 5, and 6. There are 6 carbons. So 6 begins with the prefix hex. And all alkenes end with the word A-N-E. I'm just underlining the A-N-E. So his name is hexene. Could you all quickly send me the molecular formula for hexene? What is the molecular formula? Right? And there are 2 ways we can do it today. We can do it the long way by counting the amount of carbons and hydrogen. If we count the amount of carbons, we know it's 6. So we know it's C6. And if we count the amount of H's, I know I'm going to get 14. But there are 2 ways we can do this, right? We can physically count up the amount of carbons and hydrogens, or we could use the formula for an alkene. Remember, the formula for an alkene is CnH2n plus 2, where N is the amount of carbons. So if you replace N with 6, we get C6. That means we go to the formula and we replace any N's we see with the number 6. So 2 multiplied by 6 is 12, plus 2 is 14. So either way, we would have gotten C6H14. So far, right, I have not explained what an isomer is. All we did so far is revise how to name an alkene. So where does the isomers come from, right? So I'm just erasing this little piece here. All I wanted was the molecular formula. Remember, I didn't ask for the empirical formula or the shortened structural formula. All I wanted today was the molecular formula. And there's a clarity. I'm not saying it over and over, but the molecular formula is just simply C6H14. So what is an isomer? Well, how about this? If we take hexane, and how would you say? If we were to rearrange the carbons and hydrogen. So let's rearrange it. Over here, I have 5 carbons. 1, 2, 3, 4, 5. Let's rearrange this and put the carbon over here. So I take this carbon and I bring it downwards here. So it doesn't form a how you say, a straight chain. It has a branch now. Let's just rearrange the amount of hydrogens to suit. Do you all remember how much branches or how much sticks of glue or bonds needs to come off every carbon? Do you all remember from last week? Each carbon must have how much bonds? Each one must have 4. So I'm going to put 4 here, right? Out of each carbon, I'm going to make sure that each one always has 4 carbons, so 4 bonds coming out of it. All right? So it's going to put, oh, that's a terrible color for this. I'm going to just use the black, right? So you have H here, H here, H here. I know it's kind of squished up, right? But if you look at it, right? Each carbon has 4 bonds coming out of it. Choose any carbon and you will realize that, right? What kind of alkene is this? Do you all remember last week we ended class on something called a branched alkene? Branched alkenes? Could you all name this branch alkene for me? I need for you all to name it for me. What's the name of him? You have to go back in your notes, right? To name a branch alkene, that's the one with the C and the number sign. I made you all take down a formula last week. Go back in your notes and see if we can refresh your memory. Yes. When you are naming a branched alkene, right? You look at the main chain. Well, I usually call this like the trunk of the tree. So the main chain or the trunk has how much carbons? 1, 2, 3, 4, 5. So you just name that first. So 5 means pent. Remember, if you look back at your chart, 5 represents the prefix of pent. And all alkanes end with ene. So it's pentene. Now we look at the branch. Now some people are confusing the branch. What exactly is the branch? Is the branch this? Or is the branch, let me get a different color, this? Is the branch the 2 C's or just the 1 C coming off the main chain or the trunk? Remember last week we spent a lot of time clearing that up, right? I know I spent a lot of time clearing that up. The actual branch is just this. He is the branch. The branch has how much carbons? 1. So 1 means meth. And all branches end with Y, L. Okay? So it's methyl, and there's no space between the Y and the P. Now you have to ask yourself, which carbon does the branch come off? If we walk from the left-hand side, the shortest way to reach the branch is via walking from the left-hand side. So here's my first carbon and here's my second carbon. The branch comes off the second carbon, so it's 2 dash. The 2 means it comes off the second carbon, methyl pentane. All right. Oh, sorry. Somebody, is it LY or YL? Could you all correct me? It's YLN. Oh, Lord, my mistake. Sorry, guys. Had a rough morning. It's YL. Sorry, my mistake, right? Right. Okay. Now here's the strange thing, right? The hexane, which is this guy here, right? Remember the first guy, right? How much carbons did he have? 1, 2, 3, 4, 5, 6. 2-methylpentane has how much carbons? 1, 2, 3, 4, 5, and 6. Could you all give me the molecular formula of 2-methylpentane? Remember, the molecular formula just tells you the amount of carbons and hydrogens. Could you all do me a favor? Count up how much carbons it have here and count up how much hydrogens it has there. And you're getting the same exact amount. You're getting C6H what? 14. Both of these have the same exact molecular formula. But do they actually look the same? Quick question, answer that question on the chat. Both hexane and both 2-methylpentane have the same molecular formula. But do they look the same? The answer is no. These are called isomers of each other. What are isomers? Well, what the little monsters telling us here. Isomers are molecules with the same molecular formula. But look at it, both of them have the same molecular formula, but they have a different arrangement. The atoms, the carbons and hydrogens are arranged differently. So quick question. If I tell you, and this is all I tell you go to the chemistry store or the chemical store and buy C6H14. That is all I tell you. That is all I ask you. Will you know which one to buy? Will you know whether to buy hexane or will you know to buy 2-methylpentane? Is the instructions I gave you there clear enough to specify the exact chemical that I wish to purchase? No, right? And that's why I kind of don't like the molecular formula. You see, molecular formulas don't actually specify the actual compound. To know the actual compound, you have to either fully draw it out or send the actual name. Now, if I told you to go buy 2-methylpentane, you know exactly what to buy. But if I tell you to go and buy C6H14, my next question is, which version of it? So far, I know 2 versions of it. Those are called isomers, okay? But here's the thing. Sometimes you can have more than 2 isomers, right? These are 2 isomers, by the way. Each of them is an isomer of each other. Isn't there another isomer we can create? How about this? I take 5, there can be 3 or 4 versions of isomers. Instead of putting the branch over here, if I move the branch over here, so let me just quickly do that for you guys. If I move the C over there, could you all name this alkene for me? Could you all name this one for me? And he's still an alkene because he only has single branches. Great. Remember, the main trunk here or the main chain still has 5. So he is still pent in. The branch still has 1 carbon. So he is meth YL, right? But this time, the branch, if we walk this way, doesn't it come off the 3rd carbon? 1, 2, 3. Even if we walk the other way, it still occurs at the third carbon, 1, 2, 3. So in this case here, it's the branch is equidistant from either side. So you have no choice but to put 3 because there's no shorter way to reach the branch. Both ways give you 3. And guess what? If I ask you for his molecular formula, it still has 6 carbons, and I guarantee you, if you count up the amount of hydrogens there, you're still going to get 14. Look at that. We have 3 isomers, right, of the same alkane. Oh, by the way, do you think in a reaction, hexane, 2-methylpentane and 3-methylpentane, will they all react exactly the same? Like, let's say we went to the lab and we mixed them with acid or something. Let's just use our imagination. Do you think they will all react exactly the same? Or do you think they will react slightly differently? I think they will react slightly differently because these 3 are not the same exact molecule. They have the same exact molecular formula, but they are arranged differently. I mean, all of them will react similarly, but similarly is not the same thing as same. They won't react the same exact way in our experiments, okay? Take down everything on the screen properly. I've given you 2 minutes. Let me know when you are finished, and we will move on. You cannot put a branch at the end. If the branch is at the end, the branch always has to be in between. The branch cannot come from the first C or the last C. It always has to be in between. Right? Just take my word for it, right? The branch always has to be in between. Whenever the branch is at the end, it does not change the name of the compound. If the branch is at the end, it will still be regular boring hexane, right? Right? And of course, you can put the empirical formulas if you wish. If all 3, quick question, if all 3 has the same exact molecular formula, will all 3 have the same empirical formula? The empirical formula is when you reduce the numbers. Yeah, well, obviously it would be yes, right? Because for him, and you can divide 6 by 2 and 14 by 2, so you get C3H7. For all of them, if all of them have the same exact molecular formula, you can reduce all of them to this. So that means all of them by default have the same empirical formula. All right, so let's move on, right? Let's see what else is on the next slide here. All right, so the next question is this, right? How the examiner will ask you a lot of time in the exams for specific reactions you have to memorize involving alkenes. The examiner might ask you, what will happen if you try to burn an alkene in the air? Well, it's really the oxygen in the air that reacts with alkanes. So we're going to be discussing that. Alkenes undergo specific types of reactions called substitution reactions, and alkenes can be cracked. Obviously, none of these things make any sense at the moment, right? Take down these 3 things. These are reactions of alkanes. And by the way, alkanes are what we call saturated. Anything with only single bonds in chemistry, but in organic chemistry, once it only has single bonds and no double bonds and no triple bonds, you just call it saturated. You don't have to worry about why they call it saturated. Just know what saturated means. So all alkenes by default are considered to be this thing called saturated because they only have single bonds. So anyway, take down everything on the screen and we're going to discuss the 3 types of reactions you have to memorize for the CSEC exam, right? Oh, we continue our little story here. I think you all deserve a small break there because you did a lot of work. All right, so it seems that Mr. Pelagio has finally found the gold in the Gasperi Cave. So anyway, let's move on.
After many days, Pelagio finally found the gold. It was more gold than he could ever need in lifetime. He tied a rope to his chest and dragged it out the cave. It was almost sunrise.
With this gold I can do anything, even by my innocence. Ah.
All right, so Pelagio seems very, very, very happy, right? So he walks out of the cave. Now remember, the larger bless told him that his sun will appear when his sun is going now rising briefly. So Pelagio only has a few moments to give the Duendes half the gold so her son can be freed. And this is her son here. You see him with his hat on. For those who remember from last week.
Upon leaving the cave, he saw the Duendes with Fernandez. But gold and greed is potent mixture for betrayal. Pelagio tells himself half the gold is too much and the Lajables' son is not worth it. He takes his gold and heads back to Porto, Spain, using a different path so he does not encounter the Lajables.
How much of you all predicted that this is exactly what Pelagio would have done? That he would have not, right? He would have not shared that goal. And I think all of us would have done almost the same thing. All right. Human greed. All right. Let's move on. All right, so we're gonna move on. Well, move to the first, how you say, the first reaction of alkene. Okay. Alkenes burn in air or oxygen. One of the most popular places you can find alkenes is in your kitchen stove, right? And when you light the stove, don't you all see a kind of bluish flame? If your stove is clean and you don't have any dirty pots on it, when you light the stove, do you all notice that the flame just be a kind of bluish color? I know sometimes it just be a kind of orangish color, but that is when your stove is dirty, right? The truth is, alkenes burn in air or oxygen, and because when it burns, it produces heat. It produces a blue flame, and that blue flame, hot flame, obviously, can be used to cook food. Let's look at this reaction here, right? And it's very, very important to note, when you burn alkenes, there's two things. The color of the flame just be blue, clean, and non-smoky. Think about it. If you light your stove and your stove is clean, you didn't put no pots on it, you just light the stove, do you all see any smoke coming out of that flame? Think back and let me know in the chat. Do you all really, really see any smoke? No, it's a clean flame. If your stove is dirty, then you get an orange flame, and then you begin to see a little bit of smoke. But once your stove clean, I guarantee you that flame will have no smoke coming out of it. Okay, great. Who can tell me what's the name of the alkene we are burning in today's equation? Who can tell me what's the name of this alkene? This is the molecular formula, by the way. What's the name of that? Well, what do you call an alkene with one carbon? Right. Not butane, it's methane. Look back. Methane. Met means what? One carbon. And we're going to burn it with oxygen. O is for oxygen. When you burn methane with the oxygen from the atmosphere, from the air, you get three things. You get CO2 is carbon dioxide. You get H2O, but you get the gas form. This is water vapor. not liquid water and gas water. And you all know, but I'm going to write it in here, right? CO2 is what? Carbon dioxide. Anybody knows what this means? Triangle H negative VE. What does that mean in chemistry? That means heat. Because when you burn the alkane, when in this case methane, the flame just be hot. So this symbol means triangle H negative VE means heat. It means, I'm not going to write down this, but it means it's an exothermic reaction. For those who are a little bit more familiar with chemistry, an exothermic reaction produces what? Heat, right? Okay, so I already balanced the equation for you and I put in all the state symbols. I needed to take down everything on the screen and I needed to memorize that equation for the examiner, for the exam, right? It have a lot of, organic chemistry has a lot of stuff you just have to memorize. Like you understand the basic concept, but the majority of it is memorization. So take down everything on the screen, right? Let me know when you are finished. Right? The name of the triangle, in case you're wondering, is delta. Right. This one here, right? Let me talk it through first. This one, I'm drawing it out first, and then I will write the reactions, right? If you look closely on the screen here, right? Who can tell me what's the name of this alkene? What's the name of this alkene here? This is the full structural formula. What's his name? Right? It's easy, right? He is what? Methane, because he has one carbon. But in other words, he's the simplest alkene you can have. So his name is what? Methane. And over here, we are going to mix methane or methane with chlorine. Now, chlorine is diatomic, meaning that chlorine from your periodic table usually exists as a pair. So here we have chlorine. Now, I want you all to use your imagination here. Let's say we decide to mix methane and chlorine. What the chlorine will do, right? This chlorine here, he will say, hey, I don't want to be here anymore. Any one of them, right? One of the chlorines is going to say, hey, I don't want to be here anymore. I want to go and live by methane. So what he will do, this one chlorine will walk, and he will meet a hydrogen and kick out this hydrogen. Now, if this chlorine kicks out this hydrogen and takes his place, look at it here in the next, you see what happened here? The hydrogen used to live here and chlorine kicked him out. When this hydrogen gets kicked out, won't he look for a place to live? Guess where he will go? He will go where the chlorine was living. You all see what happened here? The H ended up here. Everybody okay so far? That the chlorine kicked out one of the H's from the methane, and the H being kicked out needed a place to live. So he went and joined the other chlorine. You call that a substitution. That's an example of a substitution. In football, when you make a substitute, doesn't somebody come on the field and doesn't somebody have to leave in place of that person coming on? It's almost the same thing. Methane comes like the football field. So chlorine comes in, and guess who leaves? Hydrogen, right? So everybody with me so far, right? I just want to make sure, right? I don't want to go back after I reach the end, right? And the thing about it, only one chlorine can come in at a time. Both chlorines cannot go in at a time. So one chlorine goes in, and it could be any H. It doesn't matter which H it kicks up. I just chose the closest H. And then the H in response gets kicked out. All right. So this is where we have reached so far. Over here, notice the chlorine has replaced one of the H's, and the H is over here. So let's look at the molecular formulas here. At the beginning, I think everybody can agree that this is CH4. And you have what here? 2 chlorines. So you call it Cl2, or chlorine-chlorine, right? After the substitution reaction, do you think his name will be the same? Do you think it's okay to call him CH4 again? Well, what do you all think? Do you think his molecular formula now is still CH4? The answer has to be no, right? Won't this make more sense now? It has 1 carbon, how much H's? 3 H's and 1 chlorine. Doesn't that make more sense now? And what is his name? He is no longer Cl2. He is what? HCl. What would happen now if we take CH3Cl, that's this guy here, we just move him across here. Remember, he is CH3Cl. What do you think would happen if we take him and mix him with some new chlorine? So we mix him with some new Cl2. So it's a brand new Cl2 molecule. Do you think the same thing will happen? This chlorine will say, boy, I don't want to live here anymore. I'm going to go over here and look for a hydrogen to kick out. So this chlorine will do the same thing the last chlorine did. He's going to go to this structure and say, hey, I'm going to kick out a hydrogen. And look what happens. He kicks out this hydrogen. Look at it here. So what is his molecular formula now? See, he only has 2 H's. And how much chlorines he has now? Cl2. And of course, he gets some HCl here because this hydrogen goes over here. You all see what the chlorine is doing? That chlorine is real sneaky. He's the worst. He keeps going over and kicking out hydrogens. If we continue this process, right? Let's say we do this one more time. If we do this one more time, who can tell me what the molecular formula will be? Like if we take CH2 and Cl and mix it with more chlorine, what do you think it would end up being? You'll realize that the hydrogens are getting less and the chlorines are taking over and getting to be more. Right, you're catching the concept, right? It will be, I run a lot of space, right? So I'm writing it over here in this little cloud. It will be C, the H will get reduced by 1, so it would just be CH. You don't have to put the 1, but then there will be what? Cl3. And if we do it one more time, won't we get CCl4, meaning that there will be no more hydrogens? Eventually, if we keep this substitution process going on over and over, eventually all the hydrogens will get replaced. And you will only have what? Chlorine. You don't have to take down anything here, by the way. This is just my full diagram to get you to get you comfortable with the concept that the H's are slowly being replaced. You can think of the chlorine as a kind of parasite. He's one of those people you don't want around you because he's so sneaky. The minute you turn your back, he's gonna thief the spot of one of your hydrogens. Okay? Great. So let's put this in an equation form now. Let's put this in an equation form for you guys here. Oh, by the way, chlorine belongs to what part of the periodic table? Remember, he's group 7. What do you call the elements in group 7? It starts with the letter H. What's the name of the group of all the elements found in group 7? The halogens. all halogens, well, most halogens like chlorine, bromine, and fluorine, and all of these things have the habit of doing this with alkenes. Whenever you put an alkene, it doesn't always have to be methane. It can be methane, ethane, pentane, hexane. Whenever you try to mix an alkene with any halogen, the halogens is try to steal the spots of the hydrogens. And how it's doing it one by one, you notice it didn't try to replace all the hydrogens at once. It was sneaky. It did it one by one by one. You call that process substitution, and alkenes undergo substitution reactions. So anyway, let's go ahead over here to the next slide. I know this looks complicated, but follow me. Don't take it down as yet, right? You start off with CH4 and you add chlorine. We saw when we did that, you notice it starts off with 4 hydrogens, and now it has 3 hydrogens because the chlorine take its space. And guess what you do? Oh, that's a bad color, this one. Hopefully this will show. You take the CH3Cl that just got made and you mix it with new chlorine. And what happens? You notice the CH3 was reduced to H2, and now it have 2 chlorines. And then you take this new product and you mix it with new chlorine. You'll realize as we go downwards, the amount of hydrogens getting less and less, and the amount of chlorines getting more. Look at the final product. Look over here. At the end of this full reaction, at the end of the 4 reactions, there are no more hydrogens because all the hydrogens got substituted out very, very sneakily by the halogen called chlorine. So remember, his name was what? Methane, right? His name is what? When it have 1 chlorine, you call it chloromethane. Whenever it has 2 hydrogens, whenever it has 2 chlorines, you call it dichloromethane. Di means 2. Whenever it has 3 chlorines, you call it trichloromethane. And whenever all the hydrogens get replaced and you have 4 chlorines, its name is what? Tetrachloromethane. You see this sequence here? You have to memorize it for the exam. But it's not too hard to memorize, right? Because it's just a matter of realizing, wait now, the amount of hydrogens getting less and the amount of chlorines getting more, one by one by one. Take down everything. It will take a little while to take this down properly, yeah? And you have to memorize the names, chloro, di, tri, and tetra, right? Right? Let me know when you guys are finished. This is a classic question in organic chemistry, right? The substitution reaction of an alkane with a halogen. Now, it doesn't have to be chlorine. It can be bromine also. Bromine is also a halogen. All right, so this one looks a little bit complicated, but it's very, very easy. Alkenes can be cracked, meaning that when you crack something, that means you're splitting it into 2 different pieces. Like if you have an egg, if you crack an egg and you're breaking the egg into 2 pieces, now tell me something. I mean, on a microscopic scale, or even a not so microscopic scale, if you crack an egg in 2, is each half exactly the same size? Be honest, do you always get it exactly half and half when you crack an egg in 2? No, right? And one piece is going to be bigger than the other, right? So alkenes, what you can do is take a big alkene. This here is heptane, right? And we know it's heptane because it has how much carbons? 1, 2, 3, 4, 5, 6, 7. And his molecular formula is C7H16. Now, you don't have to worry about why we want to take alkenes and break it in two. That will be later on. But it's very, very useful sometimes to take a big alkene like heptane and break it into two pieces. But to break it in two pieces, you can't do it with a karate chop, or you can't just jump on it. To crack it in two pieces, you just have to apply plenty heat. You just have to heat it up a lot and apply a lot of pressure. You usually need a very big factory to do this, to apply that amount of heat. And later on, it's one of the last things we will be doing in organic chemistry. I will be very specific about how much heat to apply and how much pressure to apply. And you have to memorize the values, but that's for the last part of organic chemistry. But when you break it into two, it doesn't break down the middle. It doesn't break exactly in half. If you all notice, it breaks up into something called pentane. It has 1, 2, 3, 4, 5. And then it breaks up into this thing that has 2 bonds. So he is no longer an alkene. His name is ethene. And one of them will be an alkene and the other one will be an alkene, which is what we're going to start off to discuss next. So anytime you take an alkene and you crack it, you get 2 pieces. And one will be an alkane and the other one will be an alkene. And it's very easy to spot an alkene. It has a double bond between the C's. Remember, alkenes do not have a double bond, right? And on the first day of class, I gave you a list of all the different types of organic compounds. It had alkenes, alkenes, and then alcohols and a few other after. And you'll notice the amount of carbons add up to be the same. Heptane had 7 carbons. When you break it up into 2 pieces, you still get what? 7. Okay? Right? So take down, just take down everything on the screen here, right? And like I said, all you have to remember for this is that when you crack an alkene, you get 2 pieces. One is going to be a regular, boring, smaller alkene, and the smaller one is always going to be an alkene. Let me know when you are finished. Let's go. All right, so Pelagio is trying to avoid the larger bless, right? Because, you know, I think she's going to be pretty angry with him, right?
Pelagio was almost out of the forest when the Lajables appeared. Her eyes were full of anger.
Right, so I guess she has a right to be angry, right? Because, you know, obvious reasons.
He gave you gold for 10 lifetimes and you didn't miss one thing that he grieve for. You mortals are all greedy and you shall suffer the same fate as the others.
All right, that's a very heavy accent there. Half the words were kind of unrecognizable, right? So, but you'll get the idea. She's going to punish him somehow. Let's hear what's going to happen. What do you guys think she is going to do to Pelagio for not saving her son? Right, so apparently the larger bless uttered some words and let out a scream. Soon Pelagio could feel his body becoming stiff. His joints could not move. His face.
The Lajables uttered some words and let out a scream. Soon Pelagio could feel his body becoming stiff. His joints could not move. His face hard as bark. He was now a tree. He was part of the forest.
Poor Pelagio. turned into a tree by the larger bless.
This is the preach for greed and betrayal mortal.
All right. So only one thing is left for Pelagio to do for dramatic effect. He has to shout out his last words. Oh, something's wrong with the audio, but don't worry.
As Pelagio's mouth began to freeze into place for the last time, he shouted his last words.
What do you think his last words are going to be, guys? What do you think his last words as a human is going to be? Ah, you all guessed it. It's a dramatic no. Let's say it one more time. Poor Pelagio. All right. So we haven't done alkenes as yet, right? Well, we're setting up ourselves for the explanation for alkenes. Alkenes are anything with a double bond between the carbons now, right? So for the exam, you have to know some uses of different types of alkanes. Remember, it have different types of alkanes. It have methane, ethane, pentane, hexane, heptane, octane. It have so many different types of alkanes, right? And you have to know how they are at room temperature. So anytime, well, for example, to understand this, right? The states at room temperature and pressure, any alkane with 1 to 4 carbons are gases. So things like methane, ethane, which is propane and butane, anything with 4 carbons, those alkanes are gases. If the alkane has between 5 to 17 carbons in it, they are liquids. Anything with more than 17 carbons, like if you have 20 carbons or 40 carbons, it will be a solid at room temperature. Also, all alkanes are colorless. They have no color. They're transparent and they don't have a smell. You have to know this for the exam. And what are some uses of alkanes? Well, we saw today that we can use it as fuel. Things like methane, ethane, and propane, especially propane. The propane is the one it is found in the gas tanks, the one it is buy from NP, right? The same one in the kitchen. That's propane, the one with 3 carbons in it, right? And here, and you all can read through the other uses, right? I'm going to read it through to make to be boring or whatnot. Read through everything, and of course, I don't have to tell you this again. You have to memorize this table for the exam, but read it, write it down, and let me know when you are finished. Let's go. All right. By the way, that light outside the cave is moonlight, in case anybody looking for a flaw there. All right, so let's see what the larger bless does now.
The Lajables once again journeyed to the caves to put back the gold in the hopes that one day a person would do the right thing or break the curse of the doings.
All right, so the larger bless is the one that puts the gold in the cave. He sets it there, hoping that a good human, will find it.
My dreams whisper that the word, Serro, will bring my child back. But I know not what it means.
Anybody knows what that word means? Serrat? What does the word Serrat mean, and why does she think that is the word that's linked to her getting her child back? Think about it.
The truth is, after the doings take half the gold, they will ask for the next half, and only if the human gives up the second half will they let Fernandez go. Do you think the Lajables will ever see her son again?
What do you think? So it's more complicated than just giving the Dwens half. The human has to do what? Give the Dwens half. and they will ask for the next half. So you need a human who's really good, who will give up all the goal. So anyway, this is the end of the story.
The story ends when a man by the name Torres arrives with his family on the shores of Porto, Spain in the year 1629. They have heard the legend of the gold that dwells in the Gaspery caves, and they too seek its fortune.
Anybody see why this is a happy ending? Anybody figured out the mystery? Move on. Still have some time. All right, so we're now going to move on to something called alkenes. Yeah, don't forget the time there. Alkenes are different to alkenes. Remember, in first day of class, I told you the words alkenes and alkenes are spelled so close together. It's normal for students to mix them up, right? I used to mix it up in school. Well, I used to mix up everything in school. So, all right. So we have the story is finished. So we have a game to play. So everyone get a scrap piece of paper. And while we start alkenes, we will play a game. So everyone get a scrap piece of paper and let me know when you're ready. It goes. Here's what I need for you all to do. There are a lot of items on the screen. Choose any 3 items, right? And write them down, right? I'm going to play with you all because I can't remember the answer for where everything is located in this game. Choose any 3 items. I'm going to go with the hat, the skull. So I'm choosing the hat, the skull. You don't have to choose what I choose, and then the shield, right? Shield. You write down your 3 choices because you will forget. Me too, I'm writing it down. Hat, skull, and shield. What's going to happen throughout the game, you're going to get to choose items, and whoever gets all 3 items first wins. So when you get an item, you scratch it off. Right? It's almost like a bingo with pictures. As you get your items, you scratch it off. So let me know which ones you choose on the chat. All right. So you're getting your first pick. You're just the start of the alkenes. Choose one of the characters. It's either you choose the goblin, the witch, or the dragon. Who do you think will be lucky for you, like to give you an item? You make a choice. I'm going to go with the witch, right? I'm going to choose the witch. Let me know which ones you choose. For those who chose the goblin, he gave you the samurai and flower. So if you chose the goblin and one of your items was the samurai or flower, or both of them, scratch it off. For those who chose the witch, her items are the camel and the shield. And for the dragon, giving you the dragonfly or elephant. I chose the witch, so I got 1 item. I got the shield. So I'm able to scratch off 1. If you get 2 items, even better. All right, so I guess then you all know how to play the game now. All right, so let's move on. So what is an alkene? Now, alkenes have a slightly different general formula. Let me write back the formula for alkenes here. Remember, alkenes, the general formula was CnH2n plus 2. It had a plus 2 at the end. For alkenes, it's just CnH2n. It does not have a plus 2. So once again, The general formula allows you to calculate the amount of hydrogens, provided that you know the amount of carbons. All right? So in other words, if I had C3, the amount of hydrogens would be 2 by 3, which is 6. In other words, the amount of hydrogens in this particular formula will always be twice the amount of carbons. Now, alkenes are considered unsaturated because alkenes have this double bond. If you look at all of them, it has a double bond. Don't worry. I know somebody's going to ask if it can have more than one double bonds. Not for the CXC syllabus, right? For the CXC syllabus, it's just one double bond that we are going to be considering for all our questions. And you will notice all the carbons, any carbon you choose has 4 bonds coming out of it. Like if you choose him, he has 1, 2, 3, 4. Even if you choose him, 1, 2, and he has 2 bonds here, 3, 4, right? So it still sticks to the rules that the carbons must have 4 bonds attached to it. And naming alkenes is very easy. All alkenes end with ENE. Let me show you how simple. The first one has how much carbons? 1, 2, 3, 4. 4 is what? Bute, right? And because it's an alkene, it's butene. Do you all think you all can name the second alkene for me? What's the name of the second alkene on the screen? It's very easy. No tricks or nothing. Right. He is pentene. Right. Now, here's the thing, right? One more small little alteration here. You always have to ask yourself where the double bond occurs. To reach the double bond, which side is it easier to reach it from? The left-hand side or the right-hand side? Which side would you walk from to reach the double bond faster? The right-hand side, right? This one. If you walk this way, the double bond, like if you're walking this way, is connected to the very, very first carbon. Because if you stand on this carbon, you could easily take your hand, right? You could easily take your hand and touch the double bond. So when you're naming the alkene, you have to kind of state where the double bond occurs. The double bond occurs on the first carbon. So there are 2 ways to write it. You put 1 dash butene. This one here, if you walk from the right-hand side, you will bounce up the double bond on the very first carbon. So you call it 1 dash pentene. The 1 means the carbon, the first carbon touches the double bond, right? Great. Or there's another way to write it. But1ene. Sometimes they put the number in between the name. Pent1ene. This is the underneath way is the preferred way. Well, for me. But if you write it like how it's on top, it's also correct. But your teacher will ask you to do it the way underneath. They just want the number in between the name with 2 dashes. Okay? Right. By the way, in these examples, are any hydrogens missing? No, no hydrogens are missing. If this carbon, the point is, all carbons must have 4 bonds coming out of it. Because it only has 2 free bonds, it only has 2 hydrogens. If I were to put an extra hydrogen, how much bonds would it be? 1, 2, 3, 4, 5. You're not allowed to have 4 bonds. Okay? By the way, this naming thing here where you put it in between is only for alkenes, not for alkanes. Only for alkanes. Right? Alkanes do not have double bonds. So you will never have to write it like this. This naming structure, once again, is only for alkenes. All right. So we just named these two alkenes here, right? We just named these two alkenes, and we don't have to go through this again, right? This is the, well, let me change up the question. Let me just erase something here. For this one here, if I erase this double bond here and put the double bond over here, now I know I'm gonna have to rearrange the hydrogens, right? Right. 1, 2, 3, 4. That's not 1, 1, 2, 3, 4, 1. Right. That's rearranging it here, right? So what would be the name of this alkene? Look at where the double bond is, right? Send the name of the second alkene that I will alter there. All right. So it has 5 carbons, right? 1, 2, 3, 4, 5. So we know it's pent something. And where is, to reach the double bond, isn't it easier to walk from this way? Because you just have to walk on 1 carbon and 2 carbon. And once you're on the second carbon, you can take your hand and touch what? The double bond, right? So it's pent 2-ene, right? This is the preferred way, where the number is in the middle, right? I mean, don't get me wrong. If you put 2 pent-ene, it's still correct. It's just, I know your teacher is going to want the way on top. And let's write about that neater. 2 pent-ene, right? Either one is correct, but like I said, the one on top is the preferred one in most high schools, right? Right, so this is not a hard question. You don't have to take down anything. It's pretty straightforward, right? And once again, you know it's an alkene because there's a double bond in between the carbons. There is a double bond. Right? You pronounce it pent-2-ene, just like how it's written. All right, naming this alkene. All right, so anybody want to name that one? It's pretty easy. I'm not too sure why I have such an easy question. Name that alkene for me. There's no such thing as methene. And I want to explain why there's no such thing as methene. That doesn't exist. Nah, somebody had it wrong. Somebody had this wrong. All right. So I have a question here, right? The monster is talking about isomers. Creating isomers of alkenes is very, very easy. Isomers are when it's the same amount of carbons and hydrogens, right? But it's just rearranged different. For alkenes, right? Let me just erase a few things here, right? If I move the double bond over here, So I move the double bond over here. So let me erase this bond here, right? I know if I move the bond, I have to rearrange the H's. So these two H's will get reassigned to over here and over here. You notice all I did was move the double bond. I just moved the double bond and I rearranged the hydrogens, right? What would be the name of this alkene now? Now that you know I have moved the double bond, what's the name of that alkene? Right, and you're getting it, right? That's hex 3-ene, because the double bond is on the 1, 2, 3rd carbon. You see these two, the one we had before and now, you see when the double bond moves to a different space. Remember, if you move the double bond, you will have to move the hydrogens around. But if you displace two hydrogens, the two hydrogens go back to just two different spots. But the point is, it has the same amount of what? Carbons and hydrogens. Like this one, the one before had 1, 2, 3, 4, 5. The one before was called C6H12. Even when I move the double bond to a different place, it's still C6H12. The molecular formula is the same, but the arrangements of where the double bond is and where the hydrogens are different. Isn't that like a key definition of what an isomer is? Isomers are when the molecular formula are the same, but the C's, H, and in this case, the double bonds are just rearranged slightly. So it's very, very easy to make an isomer of alkenes. Do you think that hex 1-ene and hex 3-ene, do you think they react the same exact way? No, they are slightly different. So, I mean, they might react similarly, but when you zoom in on it and you analyze it properly, you're going to realize, wait, no, they don't react the same exact way, right? Right, and of course, you could reduce it to the empirical formula, but we're talking about the molecular formula right now. The molecular formulas are the same. All right, so you don't really have to take down anything here, right? I have some more examples of isomers coming up, right? Right, so remember how we said that alkenes react a certain way. Remember about, I would say half an hour ago, we had to memorize 3 reactions of alkenes. We also have to memorize some reactions of alkenes, okay? So we might be able to finish it today. I know it's 1:45, right? See some of you all are reminding me about the time already, but all right, let's at least get through this slide, okay? Let's at least get through this slide, okay? The 2 main reactions or categories of reactions for alkenes is that alkenes burn in air or oxygen. However, when alkenes burn in air or oxygen, it does not produce a clean blue flame. Remember, alkenes, that's the one before. When you light it on fire, it burns with a nice blue, clean flame. Alkenes, things like ethene and butene and pentene, if you light it a fire, it will burn with a yellow, smoky flame. The flame will actually look like this. So do you think it's a good idea to put alkenes in a gas tank? Well, what are your thoughts on that? Do you think it's a good idea to put alkenes? No, it's really, I mean, it's not. I find that's a terrible idea because every time you light your stove, it will produce a set of smoke in the kitchen, unnecessary smoke. That's terrible. And here's a reaction. I know it's hard to see. I'm real sorry about the bad choice of background color here. But C2H4, what's the name of this alkene? C2H4. What's the name of this alkene? Guys, let me just clear up one thing here, right? The name of this alkene here, he has 2 carbons, right? And I know he's an alkene because in alkenes, the hydrogen will always be twice the amount. So if the amount of carbon is 2, the amount of hydrogen will be twice, 4, right? So his name is ethene, okay? He is ethene. And when you burn them in oxygen, you get this reaction. You almost get the same thing, eh? You get carbon dioxide, water vapor, and heat. But the only problem is that you get some smoke and the color of the flame is yellow, right? And do you all remember what this symbol means? What does this symbol mean? I mentioned it before. That means heat. Okay, so this reaction produces heat. Okay, right. So we're not going to get through all the different types of reactions for alkenes today. Next week, we are going to do addition reactions. Remember, alkenes undergo something called substitution reaction when it kicks things out one by one. Alkenes do not undergo something called substitution reactions. It undergoes something slightly different, and it's called addition reactions. And don't worry, we'll handle all of that next week, right? Right, so take down everything on the screen. Let me know when you are.